This is section 16.3, talking about resistance. So we're going to talk about how you can relate the current of a circuit and the voltage of a circuit and the resistance and how it affects those. We're going to be able to classify materials as conductors, insulators, and semiconductors and relate to resistance. So when we look at the definition of resistance, think about when you resist something, you don't want to do it. I resist doing my homework. I'm going to go against wanting to do it. Resistance is the measure of how strongly an object resists current flowing through it. So in this case, we're talking about the electrons transferring through a circuit. The relationship between electric current and resistance can be compared with water flowing from the open end of a bottle. So if you have a high resistance to water flow, here it's a narrower opening. So the water is not going to be able to pass through as fast as a low resistance to water flow. It's a wider opening, so more water is going to be able to pass through faster. When we look at some analogies to resistance, it says which pitcher has more resistance. So this is basically the flow rate on a tollway. This is a road that has toll booths, like the turnpike. So let's talk about the cars as electrons. This is pictures of 3 possible toll booth situations on the highway. In the first case, we have a one-way path. So you can fit only one car through at a time. And we basically call this, what happens is a bottleneck. So you kind of got all come up to the same point. So you have multiple cars coming to the same point, but you all can't get through, so you have to take turns getting through one at a time. So that backs up traffic, so you end up with a traffic jam. Now if you take the second case, here's the first case, second case, we're going to add 2 resistors in series in a row. So you have 1, 2, 3 toll booths, but they're consecutive in a row. Resistance will be increased. Consequently, less electrons will flow through the conductor. So that's not very helpful. We look at the third case, and you have resistors in a parallel situation. So you're going to decrease the total resistance, increasing the amount of cars that can get through. So this is the one that will have the least resistance, and 2 will have the most resistance. You see situations, you can do the analogy of when you go shopping around the holidays. The mall traffic is so much heavier than on a typical regular shopping day. So your hallways that you walk through don't get wider, you have more resistance because you're fitting more people into the same area. Another analogy that you can think of is drinking through a straw. The smaller straw you have, the longer it's going to take you to drink because you can't get as much fluid through. So this is showing you the resistance. The total amount of resistance in a circuit determines the amount of current in the circuit for a given voltage. So if you have one bulb, this is called a single resistance, and you get full current. Now you have to understand that light bulbs, and depending on the size, require a certain amount of current in order to work to the fullest potential. So if you add 2 bulbs, you get twice the resistance. Because remember, we talked about resistors control the flow of electrons through a circuit, and they can be an actual resistor that's designed to control it, or it also counts as any device that uses that current that's going through it. And here in this situation, it's the light bulbs. So because we have twice the resistance, we have half of the current because you have 2 bulbs using that same current. And if you add 3 bulbs, you cut the current down even more. So it's kind of like they have to share that current amongst the three of them. So you look at the light output, and the light output gets less because you have to divvy it up between them. Electrical resistance is measured in units called ohms. This unit is abbreviated with the Greek letter omega, kind of looks like an horseshoe. So when you can measure that, I'm talking about 1 volt creates a current with 1 amp through a resistance of 1 ohm. We are not going to get into the mathematics topics of this. The current in a circuit depends on voltage and resistance. So Ohm's law relates current, voltage, and resistance with one formula. So this is the math formula, but you do not need to know how to use the equation. What you need to understand is the relationship. So talking about the three quantities, so you need to know how the current, voltage, and resistance work together. Every electrical device is designed with a resistor that causes the right amount of current to flow when the device is connected to voltage. So here you have a light plugged into a 120 volt outlet, and you get 0.83 amps of work. Well, if you decrease that to 1.5 volts with a battery, you only got 0.01 amps, and you're not going to have any light output because it's not enough voltage to get the light to light up. Same thing as if you give it too much, though, it can blow the bulb. So you have to be careful of that. You read lamps and it says, uses a maximum of whatever watt light bulb, so you are not using the incorrect, so you get the proper amount of light. Resistance can be affected by temperature and current. So a light bulb's resistance increases when there is more current because the light bulb gets hotter. Now, this is true with your incandescent light bulbs, which are really hard to find anymore because we've all gone to fluorescent. So they don't heat up as much, so they don't have as much resistance, so therefore they are more efficient. So, but the relationship that you need to know here is if the temperature does increase, you have a direct relationship where the resistance increases. So you have a positive slope on a graph showing you that if one goes up, the other goes up. So if one goes down, the other is going to go down also. We looked at conductors and insulators in the lab, and we know that conductors are necessary for the electrons to pass through. And then we also have insulators that prevent the motion. You think about wires, and if you have one big thick wire, as in this case, you have the electrons that can pass through, but they can only pass through in a certain order, kind of like with the resistance. So many gets too complicated. If you have a wire, instead of having one thick wire, have 3 smaller wires, you're going to be able to channel those electrons through better. So here's just showing the comparing of the resistance of conductors versus insulators. So your good conductors, so they have low resistance because those electrons are going to transfer very well, are your metals: silver, copper, gold, aluminum, iron. Semiconductors, these are right in the middle, so they have kind of a mid-resistance: carbon, germanium, and silicon. And your insulators have high resistance. They are not going to transfer those electrons through, so you don't get a current going through: air, wood, glass, and rubber. These are examples of actual resistors. So you will find these in a lot of appliances, and they are color-coded. So you have fixed resistors and variable resistors. And you used this one in the lab, and that's called the potentiometer, or pot, that you used to change the current going to the light. Your fixed resistors have resistance that cannot be changed, so it's consistent. Because resistors are so tiny, it is impossible to label with each of the resistant values, so they color code them. So you see all the stripes on these, and you have to organize, and they will tell you the number and figure out what the resistance is of each one. So there's multiple different types. You find these in computers, TVs, telephones, and stereos because you want a consistent control of that current going through so you don't get a spike or a decrease. Okay. And this here is an example of how you can read the code on a resistor. So you have a first digit, a second digit, the multiplier, and then the tolerance. So reading the code, it gives you the number of 2 and 5, and you multiply that by 10 times 3, and it gives you your total ohms of what the resistance is. Here is your potentiometer. This is called a variable resistor because you can adjust it. This is like a dimmer switch in your house or the dimmer switch on your iPhone to change the lighting setting. Okay, so you have a certain range that you can go to, allowing the current to go through. So turning the dial changes the resistance and changes the current or the voltage in the circuit, changing the output of your device. Here you guys did this in lab also, measuring voltage and current and resistance. So a multimeter can be used to measure a battery's voltage. And we did that, and this reads 1.5 because typical battery is 1.5. And you have to touch each end, a positive and a negative, to have the potential difference. Okay. The meter reads 0 volts if you're only on one end because you don't have that potential difference. Now, if you want the current to flow through, knowing what goes to the light bulb, you have to do each side like we did in class. And here is the current of the circuit. And remember, we talked about that it has to, the voltmeter or multimeter has to be part of the circuit to measure the current. So on my website is also a video for you to watch, and it's video number 1, so you can watch that and review over this information. There's also the resistance simulation going to the PHET Colorado website, and there you will be able to play around with adjusting the voltage and the amps to see what the current and the resistance has an effect on electricity. Please write down any questions that you have, or star or highlight things that you did not understand that you need further explanation on. Again, reference the book and read through section 16.3. That's helpful as well.